TypeScript allows us to work with one of the most important new features since ECMAScript 6, classes. Classes are fundamental entities used to create reusable components. The implementation of classes allows us to include data members to define a state, as well as functional parts in the forms of methods. In this example, we define class greeter with a field greeting of type string and two methods: a constructor, the method called when we create an instance of object of that class with the new class name statement, and greet, a method that returns a text greeting. The declaration of a constructor method must include all the usual object-oriented programming restrictions in order to enhance the consistency of the class. The this keyword always refers to the active class and more concretely to the current class instance or object generated. The methods are defined like those of any other function. They can receive parameters of any type. We can overload methods also, but in a slightly different way as usual and with limitations. In this example, we overload the method type with two variants. They differ in the parameters and the return type. Let's examine the syntax constraints. There must be a generic method that includes all parameters of the previous method with less parameters. In this example, it is the third type method that includes two parameters. This generic method is the only one that can have a body definition. The other overloading methods can only be declared. All parameters must be optional with respect to the method with the less mandatory parameters. In this case, the first drive method is the one with less mandatory parameters. The expected return types of the most generic method must include all the return types of the other methods, just like the third drive method does in this example. In fact, TypeScript overloading does not add much value, as you may have realized, except for the clarification reasons. So in this case, it will be equivalent and sufficient to leave the generic method alone since it includes everything. In TypeScript, a class can implement interfaces to enforce particular contracts. In this case, the interface task acts as a contract. The class myTask implements it, and we can declare variables of type task and assign it a new instance of type myTask. A class can inherit from another class and serve as a base for other classes in order to implement a hierarchy. In this example, the class dog inherits the class animal. Therefore, we can use the parent properties and methods from inside the dog object. Additionally, many theorists claim that the solid principles should apply here, and especially the first one, the single responsibility principle for separation of concerns. If you want to know more about how to apply the solid principles in TypeScript, visit this link. As a summary, TypeScript classes possess the following characteristics as shown below. In other aspects, TypeScript provides three access modifiers to class properties and methods: public, private, and protected. Public is the default modifier. A public member can be accessed anywhere. For example, animal is a class with its members public. That is, the field position and the method move are public and accessible anywhere. Private elements cannot be accessed from outside the class. In the example, secret speed and calc new position are private, because they are intended for inner use inside the class for the new position calculation, so they are not accessible from outside. By convention, private elements are usually marked with an underscore at the beginning of the name. Protected elements can only be accessed by derivatives of a class. In the example, class dog inherits from animal and it's able to access the protected field position in the parent class animal without restriction. Take into account that private and protected are only enforced during type checking. That means that once transpiled, the private and protected items will actually be accessible. This is called self-private. It is intentionally done by TypeScript to make easier to access for things like unit tests. For making true private members, use the JavaScript notation hashtag in the name. Besides the formal modifiers, there is one more, static. A static element belongs to the class instead of the instances. That is, it is shared among all instances of a class. For example, origin will be present in all the instances of the class grid and will have a unique value for all the instances. Another characteristic of TypeScript is that we can declare the class fields in the constructor as parameters without having to declare them explicitly as fields. In the example, the fields are declared in the constructor, and even secret speed is declared private and initialized with an init value. Aside from the previous features, in many occasions we want to intercept when a field is accessed. Getters and setters are accessor properties in TypeScript. They allow final control over how a field of an object is accessed. We use get to define a getter method for read a field value, and set to define a setter method for update a field value. In this example, the class employee defines getter and setter methods for the private property name. As we can see, when we try to set a new name value for the employee object, it is validated before it updates the object. Only valid values result in an effective update. The getter and setter methods are invoked in the background when we try to access the referred property, in this case, name. To know more about TypeScript classes, follow this link.